the integral of e to the x sine x. Well, it's going to be integration by parts. That's my dog. It's going to be integration by parts. It's not immediately clear which one should be u and which one v dashed. So let's just try one. Let u be e to the x and v dashed be sine x. Then u dashed is e to the x and v is negative cos x. And this is u, v minus the integral of v, u dashed. Substitute carefully. U, v, negative e to the x cos x, oops, got a bit messy, minus the integral of v times u dashed. I'm subtracting a negative, so that's a plus, e to the x, sorry, u dashed, e to the x cos x. It's not immediately clear that I've made any progress, is it? E to the x sine x became e to the x cos x. But actually, if we do this once more, something interesting will happen. So let's do it again. Let u... Wait. Last time I did this, I wished I had written it separately. So let me do that. But the integral of e to the x cos x. Didn't leave myself much room, did I? U be e to the x and v dashed be cos x. Then u dashed is e to the x and v is is positive sine x. So this one is equal to the new uv minus integral of v u dashed. Well, that is e to the x sine x, sine x, minus the integral of v u dashed, e to the x sine x dx. Now can you see what we've just done? This integral involves the integral that I started with. And this gives us something magic. So let's go back to this one. The integral then, therefore, the integral of e to the x sine x dx equals negative e to the x cos x plus this e to the x sine x minus the integral of e to the x sine x dx. Has that got us anywhere? Yes, it has. I can solve this. I want to work out what this is. I've got another one over here. It's subtracted. If I put it on this side, I've got two lots of the integral of e to the x sine x equals this. And I'm actually going to write it the other way around so that I have a plus minus. So e to the x sine x, minus e to the x cos x. At this point I should be adding a constant somewhere because I've got all my integrals on one side plus a constant. So now I have an expression here for twice the integral I want. So I just have to divide this by 2. Therefore, the integral of e to the x sine x equals a half. Actually, I'm going to take something else out. It's a common factor of e to the x. E to the x on 2 times sine x minus cos x plus some constant. Now this is a new constant because it's actually half the old constant. I'm not too bothered about that. If you like, what we should really do is go where C1 is half of the original C. So that was a bit tricky. I started with integration by parts and ended up with another integral that looked very similar. But because it involved trigonometry, when I did it again a second time, I ended up with an expression including my original integral. So when I substituted that in, I ended up with an expression that I could simplify for the thing I wanted.